more food. All right, cool. So I'm Sanjeev Khudanpur. You probably know that, but for those who didn't, I thought I might as well put it on record. And I'm a faculty member in CLSP since 1996. So I might be, other than David Yarowski, I might be the oldest faculty member in CLSP. So I'll tell you a little bit about our workshops. And it's important because these are some things we've been doing for a while. We are known around the world for doing it. And it creates an interesting dynamic because there are many models of research. You get a grant from NSF and your faculty member gets it and works with a couple of students or maybe two faculty members together. There are these DARPA programs where 20 universities are involved, 50 professors, 200 students, and they have evaluations and everything. This is a third model of doing research, where you say, let's bring together people on a specific topic for a couple of months and do something focused to see if we can make a breakthrough. And it's not just a one-day conference where you meet or even 3 days or a week where you brainstorm ideas. You actually are together for about 2 months and you try to make some progress. And we plan for this quite a bit, as you'll know here in a minute. So that's why these are interesting. That's sort of a third model of how to get research done. But where do these ideas come from? So this is not something we came up with. There's a long history. So long before we had these, by the way, these workshops are now called JSALT. They're named after Fred Jelinek, who was the founding director of CLSP. And they're called the Jelinek Memorial Workshops. But long before there were CLSP workshops, there was something else going on. So to really understand what the history of this, you have to go back to the 50s. So there's a place called the Institute for Defense Analysis in Princeton. And right from the 50s, they were doing these summer camps, and they called them SCAMPs, stands for some summer something program in applied mathematics, probability or something. I'm not sure what it stands for. But they used to get together mathematicians who would work on cryptography problems. And this is a legacy that started from the Second World War, where the Americans and British together had a lot of success breaking Nazi codes and so on and so forth. And they wanted to continue that. And of course, you need a lot of good mathematicians to do cryptography. And mathematicians are often free in the summer. So they used to bring some good people together, work on code making, code breaking problems. And they have had a long, successful history of doing this for many years. And I believe they're still going on. This has been going on since the 1950s, like I said, and Princeton used to do these things. And somewhere around the mid-1990s, somebody decided that we should do something about this or something like this in speech. Right? So the speech and language technologies started becoming real and people are starting to look at speech recognition as feasible. There were nascent ideas in machine translation and so on and so forth. By the way, the statistical MT paper hadn't come out yet. People were still doing rule-based and example-based machine translation and so on and so forth. And Jordan Cohen, who used to be at IDA in Princeton, the place I told you about, and Jim Flanagan, who had just retired from a high position at AT&T and Bell Labs and joined Rutgers University, they said, okay, let's start this thing. And so they put together a summer workshop like the IDA model. The IDA model was bring people together for 10 weeks and have them work on some problems. They used to create a problem book saying, these are the things we were to work on, and they used to work on it in a focused way. So these guys started something like that. And they held the first one at Rutgers University because Jim was there. And then the second one also at Rutgers. So this happened in 93 and 94. So this is sort of the beginnings of our summer workshop. And then in 95, Fred Jelinek came to Hopkins. So Jelinek at that time was a big name in speech. In fact, many people credit him with bringing statistical methods to speech recognition. And in fact, Steve Young, when he wrote an obituary for Fred, when Fred passed away in 2010, said something like, Jelinek is not a pioneer of speech recognition, he's the pioneer of speech recognition. Right? So Jelinek was our director starting in 94. And when he came here, the community decided that the workshops should be here because he was known for getting people, doing big things, organizing people. And so he decided to get the workshops here. Oh, I see. I keep getting interrupted by people who want to be admitted. Sorry about that. Yeah. And so the first workshop of this kind was held at Hopkins in 95 under Fred's leadership, if you will, right? And he sort of introduced other things. So at the Rutgers workshops, even Princeton, they mostly focused on bringing researchers together, people with PhDs, faculty, postdocs, research scientists, people like that. Fred said, no, we need to have students because students are the real lifeblood of our community. So he started bringing, hey, Brian, can you take care of admitting these people? Yeah, okay, thanks. So basically, Fred said, let's make PhD students an integral part of the workshop. And one of those PhD students was me. This was me in 95 or 96 or something. So this is the first time I attended a workshop as a PhD student from College Park. But then, of course, next year I joined Hopkins and I've been part of that. So what were you working on in 1995? Language modeling. Yes, this is not something new. Like, Joshua Bengio didn't come up with language modeling. This has been around. It's been a concern of our field for more than 30 years.
I wonder what Fred would say about all the latest developments. I mean, first of all, I think he would be thrilled that finally it worked.
I'm sure you'd be thrilled. He'd really be thrilled. He'd still have complaints about how people are doing stuff, but that's Fred, they're not doing it right. But yes. No, one of the things he is supposed to have said, and he kind of denied it, but not very vehemently, is at some point he said, really, data should be driving a lot of the things we do. And so he's quoted with famous for saying, every time I fire a linguist, the error rate of my recognizer goes down. And there's actually a story behind it. The story is that when he joined IBM in the early 80s, at 82 or something, I think, IBM decided to put together a computer science group. Fred Jelinek, there's a very well-known guy called Lalit Bal, and a couple of other computer scientists. And then they said, oh, we're going to do speech recognition. We need linguists. So they had this IBM office down in Raleigh, in Carolina, and they brought up some linguists from there. And these guys said, oh, yeah, I will help you. We'll write you some grammars and this and that, and tell you how words are put together by humans and so on and so forth. And so they tried to work with the linguists, but they found very quickly that all these grammar rules are very brittle. You can write them, but after a while, they don't fit anything anymore. And so they started going with these statistical methods. And at some point, they needed headcount. They wanted to hire more computer scientists, but management said, no, you have enough people. So then they said, okay, how about we send these linguists back to Raleigh, and we'll hire some computer scientists or information theorists. So that's what they did. And of course, the recognizer got better. So that's the origin of that quote. They didn't fire the linguists. They just sent them back to Raleigh. So that's what Fred did. But anyway, we're working on language models. Was there a question? No. Okay. By the way, online people, feel free to interrupt with questions. I probably won't see anything typed. So just, Brian, can they unmute and speak? Okay. Yeah, just unmute yourself. Okay, cool. All right. So yeah, we're working on language models, and we've been working on it since then. And as Jason said, we've made a lot of progress. We worked on pronunciation, dependency models, so on and so forth. So these workshops kept happening one after the other. And Fred sort of put in this model in place where, you would sort of start planning in October, November. But this is one of the fun teams. So one more thing we added starting about 98 was undergrads. Until then, it was faculty and PhD students. But they said, yeah, how about get some crazy kids who don't know anything and see what they come up with. And there's a quote, I don't know where it comes from, but I heard it attributed to the former JHU president, Brody. He said something like, yeah, I put together a team of undergrads and they didn't know that there was this result that said that this cannot be done. So they went and did it. So you put in undergrads, some fun things happen. So this was the first time. So the two people over here, let me see if I can, maybe I can point with this. So this is Cynthia Kuo, and this is Oren Schwartz. So these were our first 2 of 6 undergrads starting in 98. Some of the other people are, by the way, fun people. Haich is the head of the department, computational linguistics in Prague. Eric Brill retired as the CTO of PayPal. Jason, where was he?
Well, he was at eBay.
eBay.
He was not
eBay.
the CEO.
Yeah.
He was like
CTO.
Yeah, CTO.
CTO, yeah. He's supposed to have known Elon Musk from those days, I think. Yeah. Anyway, so these are fun people. They were all here at the workshop, and life goes on. We had teams in 98, 99. 99 is a good team to tell you about. So this team worked on statistical machine translation. So what happened is, that, like I said, in 93, 94, machine translation was still being done by rule-based or example-based methods. And in 94, there had been a paper from IBM about how to use statistics. But all the people who wrote that paper, the very next year left IBM and started a hedge fund. So that this knowledge kind of was left unexplored and was dying. So we put together a team in 99 to say, let's bring back all those methods. And the team was led by someone called Kevin Knight. I mean, those of us who are a little bit older than you guys know that name very well. Kevin's famous in the field. And so he led the team where David Yarowski, I think David's online, was part of that team. And these guys basically resurrected that whole idea, implemented a lot of basic stuff, did new things. And the highlight of this team was at the end of the workshop, David did what he called machine translation in a day. So he started with the corpus one morning, and the next morning he was producing translations from that language into English. I can't remember if the language was Czech or something else, but it was basically saying, give me data, give me tools, I can produce a machine translation system in a day. Because if you think about the previous methods, it would take months, if not years, to build a reasonable translation system. Right? So that was sort of the highlight of that workshop. Another thing that the workshops are well known for is that although we say we do speech and language, we always recognize these connections between various modalities, and multimodalities being central to us. So nowadays people make a big deal of, oh, let's do multimodal LLMs and maybe images and text together and clip. In 2000, we were looking at audio-visual speech recognition. How can you use the visual modality to improve speech recognition? Right? These things go on. Let's see. Not just audio-visual speech recognition. So I just mentioned clip and joint speech and text modeling. So 2004, there was a team led by Giri Iyengar from IBM. By the way, Giri is now at Capital One, and I think he's heading a pretty large machine learning team, and Manmath went to Amazon afterwards. So these guys had a team called Joint Visual Text Modeling. So they were trying to model text and images together so that you could use text-based image and video to retrieve images and videos. Right? There was a team in 2010. The person on your right is, on your left is Jan Newman, and then there's Evelyn Zuckerman. So these guys led a team where they said, hey, when you have videos with narration, and they happened to create this nice corpus of kids cooking videos. So the narration tells you what's happening in the video. It says, chop the onions and fry this and clean the carrots or wash the carrots. So they said, can we use those two together to help computers learn what's happening in the video? Because we have pretty good grounding of what the text means. So this way we can try to do action recognition and understanding in images by leveraging the fact that words and videos go together. There was another team of Alex and Tamara Berg. These are very well-known names in computer vision. Their work basically started associating text with images, and they're sort of the precursor of the clip-like models. So Alex and Tamara used to have these fun demos where you could give it an image, and the computer came up with captions like, in this image, there is one boy standing next to one bicycle behind one table. Like, it used to try to quantify how many of those things you had. It's sort of a bit amusing, but it was really nice. So this is the history of our workshops. All these things have been worked on over here long before they became popular. In fact, 2012, there was a team led by Andrea Vidaldi from Oxford. He's part of the VGG group now. And this group has a lot of who's who in computer vision. If you see names like Ross Gershik or Karen Simonian, these are people in Anthropic and OpenAI, and all these guys were students in this group. So a lot of who's who of the field has passed through our summer workshops. So this is us connecting with the computer vision community and working together on multimodal things. And by the way, so all this work we do in the summer together, does it get anything done? Well, actually a lot. And I just handpicked 4 of my favorite examples, but there are a whole bunch more. So in 2006, Philip was here. He had just finished at ISI, and he was basically saying, we need better tools to do statistical machine translation. So the Moses tools were born here in the workshop. And Philip hasn't turned back. He wrote the book on machine translation after this workshop. Then he wrote a second book on neural MT recently. Najim came up with iVectors. The reason he has his tenure is iVectors, and he invented iVectors at the summer workshop as a grad student. Right, so that's ours. We can claim Kaldi. Kaldi is, at some point, was the most widely used speech recognition tool in academia and industry. It's been taken over recently by end-to-end methods, but Dan started that work here at the summer workshop. Of course, the current dominant end-to-end speech recognition methods use something called ESPNet, which Shinji started also at the summer workshop. There are others. There's the summarization tools called Mead came out of here. So pretty much lots of very big breakthroughs, if you will, and that both tools and good science, in the sense that good science was done, but rather than just write a paper, because all these people were working together, they built tools to be able to work with each other, and then they made those tools open source, and that has driven the field forward in big ways. So we can actually claim credit for a lot of fun things over here. My addition to these workshops was that at some point I got tired of just doing everything in Baltimore. We've been doing it for almost 20 years. And I said, how about we have it somewhere else for a change? And so for the first time, we had our workshop in Prague. Jelinek, like I said, had passed away in 2010. And this is when we first called it the Jelinek Memorial Workshop, because the people in Prague, he meant a lot to them because he had helped set up the computational linguistics research in that university and advocated for them and so on and so forth. So we called it the Jelinek Workshop, and the name stuck. So we've since then been calling it the Fred Jelinek Workshop. So we did it in Prague. 2015, we went to Seattle. We were at UW, Mari Ostendorf, and someone called Les Atlas. Some of you may not know. He's very well known in signal processing. So they hosted us, and we had the summer workshop there. I don't know if you can see in this picture, but back here, you can actually see Mount Reagan. In my picture, you can. Like, the resolution is not good enough. So Seattle, of course, is a beautiful campus, as you guys know. And so this is from there. Then we started this alternate cycle. We were trying to, like, one of the funny things I was told by some people is they said, hey, don't just take it away from Hopkins. Don't make it a thing that keeps moving every year. One of the reasons is when you organize something this complex, and you'll see in a minute how complex the organization is, you need a lot of institutional memory. People need to know what to do when, right? And a lot of that institutional memory lives in Hopkins. So Ruth, who some of you have met, she retired recently, and Nicole, and all the staff here, and us, and Jason, and we sort of know what needs to be done all through the year to make this thing happen. And so they said, don't lose that. So we said, okay, fine, we'll do it 1 year in Hopkins, 1 year somewhere else. So the home base retains all the knowledge, and then we share it with others as we go. So 2017, we went to Pittsburgh at CMU. We had a great time. 2019, we went to Montreal. And 2021, well, actually, 2021, we had a slight problem. We had, this virus that was going around. So we skipped 21. And so in 23, we went to Le Mans in France, right? So, and the sequence carried on. In 25, we were in Brno, right? So what we would, other than these breakthroughs, these workshops also do these interesting things. There are these lifelong collaborations that start. So the leftmost picture is a couple of people, three people from 2001. They worked on something called the graphical modeling toolkit. There's another thing actually I'm quite proud of. Graphical models came about in the community, in the core machine learning, community. And we were one of the first people to say, hey, speech and language, we can use these ideas because we have all these complex dependencies. We want to model using these models. And so these guys created something called the graphical modeling toolkit. So person in front is one of our former PhD students, Peng Shu. Behind him is Jeff Bilms from UW, and all the way back is Jeff Zweig, who is, or was at least at Meta until recently. I don't know where he is now.
I remember he was at Microsoft for a long time.
Yeah, Microsoft and then Meta, yeah. The middle group, this is the CNTK group, the Computational Network Tree Toolkit. This was led by someone called Dongyu. Dongyu's claim to fame, if you guys don't know, is that around 2011, I think, or was it 2012? All these ideas of using neural nets for speech recognition were around. They've been around since the 80s, actually. They're not new. But Dong and a couple of other people from Microsoft took those ideas, scaled them up, and basically blew everybody's socks off by showing how much better performance you could get if you only had enough training data and enough compute. And they were like, okay, guys, we have to do neural acoustic models. So they changed the field in some sense. So there's a paper in 2011 at Interspeech or something, which people still talk about. So they had a 33% relative reduction. So they cut the error rate by a third just in that one paper on the state of the art. So that's group. And this is that group, brainstorming ideas and so on. And then the picture on the right is Franz Ock. Franz Ock, by the way, was part of that 1999 team I told you about, where David Yarowski did all that MT in a day. So Franz was a grad student in that group, went on to do a postdoc at USC, came here and led a summer workshop team, went back to Google and started Google Translate. So Google Translate comes sort of here as well in a sort of indirect way. Right? Okay, cool. So we've been doing fun things all along, and let's see. The undergrads, they contribute anything over the years? Well, actually they did. But more than contribute here, they did fun things afterwards. So remember I mentioned Cynthia Cohen, that very, very first cohort of undergrads? So she went on, and now she is basically a sort of professor of the practice at CMU West. She teaches students how to both do research and translate them into companies. So she's affiliated with CMU. You might know this guy, Noah Smith. He started off as an undergrad in our workshop. And then we recruited him to do a PhD here, and then he went on to UW, but actually first to CMU UW. This is another interesting person. I keep in touch with him, David Kirsch. He did his undergrad, did some research after that, started a company. Now he's a CTO of this company that does medical informatics, NLP, things like that. So different kinds of success, all very fun people. Rachel, she was an undergrad in our workshop, became a PhD student. Now she's a faculty member at the University of Maryland down the street. So overall, I would say good success, right? Okay, so this is sort of just a quick view of all the things that have happened in the past. How does one actually put together one of these workshops? Well, it's not just summer. Like, organizing these workshops, it turns out, is a whole year-round activity for CLSP. So we already start, as soon as the workshop ends, this is September, I'm already trying to craft a call for ideas for the next workshop. So we'll send it out hopefully this week or early next week, probably. Get people to suggest ideas. Hey, what topics are fun to work on this year? And we have a few criteria. It needs to be something that's sort of exciting, also something that is timely. Like, recently people have started figuring out XYZ. So this is a good time to see how far we can take it. Or, oh, here's a cool idea called graphical models. Let's see whether it can do something for speech recognition, things like that. So you need an idea and you need some kind of feeling that this is the right time to tackle it. The other thing we think about is what kind of expertise does it need? If all the people needed to work that idea in one university, there's no point having a workshop about it. Let them just do it in their place. But very often you need a group of people who have different skills, different ideas to come together to work on something. So we focus on whether you're bringing together interesting people to work together on things. Right? And so we do all that in October, November. We have a planning meeting, 2 days, we sit down and brainstorm the ideas. So unlike a normal idea where you submit a proposal, you get an evaluation in or out, or a paper, you submit a paper, either it gets accepted or rejected. This is very different. The people who submit the ideas and the people who evaluate the ideas, they sit down together and talk about it. So imagine submitting a paper and then sitting down with the reviewers and arguing about why your paper should be accepted, and the reviewers complaining and they say, but wait, I can do this. And they say, okay, fine, if you do that, it'll be a good paper. And then you get in, right? So that's the kind of interactive peer review we do. And then, of course, we do raise money for this and we do some of that. And already in January, we figure out who the senior members of the team are, who the PhD students are. We pick the undergrads, and we actually meet in person for a day or two, once in March, once in May. Of course, we also continue meeting online and Zoom and all that. And the idea is that you really want your team to come together, to gel before you sit down for 2 months and work on something. A lot of baseline work gets done, implement code, check out toolkits, wrangle data. You all know how much time it takes to just wrangle the data together for what you do. So all that happens in the spring, so that by the time you get together in the summer, you're ready to go. And then in the summer, of course, you go. So this past year, we started this with the same process. So here's a little snapshot of the call for proposals. I won't make you read it. I'll just say, hey, we are looking for ideas in text understanding and speech understanding and multimodal understanding, responsible AI. If you have any ideas, let us know. And if we like your idea, we'll invite you and we'll sit down together and brainstorm how it works. Right. So we did that and we got a pretty nice response. We got 24 ideas from 24 different people. Some of them we declined after a preliminary review because it didn't fit our overall goals or it wasn't the sort of scope that we needed. So once in a while, you get a grad student from somewhere saying, here's my thesis idea. Why don't we have a workshop on it? So like, no, that's your thesis idea. You work on it yourself. So things like that. So we did that. And then a few people said, oh, I thought you were just going to tell me whether or not I have a team. I don't want to come in and debate it. I don't have time that weekend. Okay, fine. So some people withdrew and 14 people came through. So we had a 2-day meeting in November last year. The meeting was here, actually. Some of the students here were involved. They came and listened to people and helped. So each proposal, at least one of the proposals come in. Plus, we invited a whole bunch of other people. Overall, there were 46 people, including the 14 proposers, plus another, you can imagine, 30-odd reviewers, right? And they come from all over. So the reviewers from academia, there were 17 people other than JHU faculty. 9 JHU faculty were involved as well. There were 17 people from industry. So this is not just an academic exercise. Companies are very interested in these topics and who works on them and so on and so forth. So there were like roughly 17 from other universities, 17 from companies, a few people from various government agencies. They typically come in to get a sense of what the community thinks the research ideas are. And they often also are trying to get us to work on problems that matter to the government, because indirectly, at least in a democracy, problems that matter to the government matter to society. So they're saying, hey, these are important problems, work on them. And sometimes they're able to get us funding once they see that the ideas we have line up with what are programs they're running. Right? So we critique the ideas, we like help the people modify or improve them, morph them. Start at Friday 6 p.m. Other than sleeping about 7 or 8 hours each night, we work nonstop to Sunday noon. So it's a pretty intense uh, atmosphere. And at the end of it, we vote on them. And one of these days, I'll have Jason give you a lecture on single transferable votes. It's a very interesting voting mechanism. We really try to drive consensus and figure out what the sentiment of the room is. And it's designed so that even though the authors of the proposal are in there, we manage conflict of interest in a very seamless way. You just mark the proposals if you have a conflict, and your vote gets held back until something gets decided about it, and then you enter the fray again, and so on and so on.
Basically, we set this up because people complained that they didn't think the decision process was fair, so we tried to make it fair.
Right. So what Jason said, for those online who couldn't hear him, he said that basically in the beginning we used to just do a show of hands and stuff, and people said, "Oh, not fair." So Jason said, "Okay, I'll make it fair." He started off by saying, first of all, there's Arrow's theorem, which says that there's no system which is perfectly fair. But given that we don't have a system that can be perfectly fair, here are the objectives, and here's a system that meets them, and then that's what it is. So maybe you'll give a lecture on it one of these days. We'll see. Anyway, at the end of the day, we voted and we came up with 3 very competitive proposals. And then, for reasons I'll explain to you in a minute, a 4th project was added later on because we have this collaboration with the European project who has money to send people to JSALT, to the workshop. So they wanted to figure out what they wanted to do as a group, and we were going to host them. So that was the 4th group. And they also went through a review, just a different one. They had to go through something ad hoc this year. Right? Okay, so we got 4 projects. So what were the 4 projects this year? Oh, the other thing that happens in these meetings is not only do you come with a project idea, we also come up with some of the core people. So one of the things people have to do is, if I suggest, hey, next year, why don't we work on doing RAG on video? Like give it some video examples and retrieve and something. I say, fine, are you going to lead it? Oh, no, I was thinking that you should work on it. I'm like, thank you very much. So people who propose these ideas, we often tell them, if you really believe in it, you have to come here for 2 months to do the work. And people want to do it. So the people who sign up who propose ideas are really committed to them. They're willing to go somewhere else for 2 months to work on it with other people, right? So they emerge naturally from them and a few senior people, because when you have these discussions, you sort of, figure out who else is interested in their ideas, and you bring people together with compatible but complementary ideas. So one group wanted to work on end-to-end multi-channel, multi-talker automatic speech recognition. Right? So why is this problem interesting? Believe it or not, speech recognition is still very, very broken in many situations. So you have multiple people talking over each other when the microphone is far away. Things are pretty bad. Right? And this group said, hey, let's take a look at this. We have a few very nice data sets over there, and so on and so forth. So why don't we bring together some people who do signal processing, some people who do microphone arrays, some people who do diarization, and see if we can tackle this problem. So this was led by someone called Lukáš Burget, who's at Brno, and Samuel Cornell, who's at CMU. And this group had 6 senior researchers, including Matt, who's sitting back there, and Matthew Wiesner, and a couple of others. Some of our PhD students were in it. And Shiloh is not here, but Shiloh was there. And we had 7 grad students, 2 undergrads, and 7 affiliates. And when I say affiliates, I mean these people didn't come there for the whole 8 weeks. They were there for just 1 or 2 weeks. So they count, but not as full members. The second group was looking at LLMs to generate dialogue. So they call themselves Play Your Part. So that's why the abbreviation PYP. But the longer title of this team is towards LLM role-playing agents that stick to their roles. So what do you mean by that? Well, so what they meant is, you can imagine, first of all, why do you need synthetic dialogue? For a number of reasons. One is to train. Very often if you wanted to train an LLM to maybe summarize doctor-patient conversations, anyone tried getting a hold of real doctor-patient conversation data? What do you think will happen? There are a million obstacles, HIPAA and this and that, and people aren't willing to share. So these guys are asking the question, what if we can synthesize dialogue that's realistic, at least for system training, right? And there are other uses that I can talk about later. But let's keep that as the role in your mind, right? And by the way, this is not completely crazy, because the way they actually train doctors is there is something called a standard patient. These actors, they know how to act. and you give them a sheet saying, oh, you are suffering from stomachache and your mother had this problem and you have this and you ate this yesterday, da, 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 go to the doctor. And so these guys walk into a room where a trainee doctor is sitting waiting for them. And then they say, well, it hurts over here. And the doctor says, what did you eat yesterday? Oh, they have the answer. So basically, this has been a paradigm that's already used in medicine to train doctors, right? So they said, what if you could have the patient be an LLM agent? Could we use that to scale up doctor training? What if we had the LLM play the doctor? Can we identify workflow issues or see what we can do? So they had a bunch of goals like that. A lot of senior members, grad students, and the three affiliates actually were doctors, actual practicing. And where is Haas? Haas is not here. Haas is one of our colleagues. He's both a faculty in School of Public Health and a PhD student in CLSP. So it's a crazy role. But anyway, he was there in this team. And it was fun. So these guys tried to say, can we do this? Can we give the LLM a standard data sheet and say, this is your patient profile, or give it a standard data sheet saying, this is your doctor profile. You are a a resident, third year pediatrics. You specialize in this, and and the patient is going to be some 6-year-old who walks in with his mother and has some issues. So they said, can we have these agents play their role and carry on a dialogue for some time? The third team, Augie, is Audio General Intelligence. So Paula is part of this team. And the idea was, can we have LLMs exhibit audio understanding? And by that, I mean not just transcribing speech or identifying speakers, just generally what's happening here. Oh, this looks like it's a restaurant. Oh, it looks like it's a Mexican restaurant because I just heard taco and tamale in the background, or whatever it is. You can imagine. Oh, there's a noisy kid in the back row, and hope somebody shuts him up soon. And whatever, you can imagine. So trying to do audio understanding. And this was led by Ramani Duraiswamy, who's a professor at Maryland, and Santosh Desiraju, who's a researcher in Brno. And this had a few senior members, lots of grad students, a couple of undergrads. And these guys were trying to improve general audio understanding.
So what's an example of something that their system was able to do?
Oh, so there is some prior work in this that is very recent, but still we should consider it prior work. So there are models like, there's a benchmark called MMAU. Paulo, what does it stand for? Massive Multilingual Audio Understanding or something. Yeah. So the questions in this benchmark are things like, here is some audio. Can you describe what instruments are playing in it? Here is some audio. What happens first? The man.
So it's audio scene understanding.
It's scene understanding. Yes. And I would say more than scene understanding, it would be, well, when people talk about audio scene understanding, they're typically talking, and this is for historical reasons. They talk about what is called the understanding the layout, the sources and their locations, and so on and so forth. This might be further. So, for example, it might say, what rhythm is this? Or what's the speed of this tune? Or what, or you might say something like, what genre is this? Or which of Beethoven's compositions is this one? And so on and so forth. So it would be things about music. You can break these down into a few categories. So there are questions that have to do with perception. Can you detect the presence of some sound? There are things about discrimination, are these the two same or different? And there are things about comparisons, which is the loudest, quietest.
The term general intelligence threw me a little bit, because when people talk about artificial general intelligence, they generally mean it can do a very wide variety of tasks.
Right. So the MMAU benchmark was a little narrow. So one of the accomplishments of this team is indeed to create a much wider array of things. So for example, there are reasoning questions one can ask about the audio. One can ask a question that says something like, what is the relationship between these two conversants? And the conversation doesn't say anything explicitly about what they do, but just from the nature of the conversation, you should be able to figure out both the lexical and the prosodic or pragmatic or whatever else you want from the audio to figure out who they are. So there are questions which you could argue involve reasoning rather than just perceiving the audio. Yes. So whether to call it general intelligence or not, well, you can have a debate with Ramani. Everybody likes to have grant.
Trying to extend the existing general intelligence such as it is to also be able to deal with audio. So this is like the audio component.
That is probably the way Ramani thinks about it. I wouldn't want to put words in his mouth, but that's probably what they think. Paula, why, you were on the team, you should say.
Before, I'm just like it was said, then this one was like to see like the position of the different speakers, open and close questions. Yeah, so this was a more general thing.
Okay, all right, okay. And then the fourth team, this was the Esperanto team, the European project. They wanted to work on low research speech synthesis. They called it TTS for all. And this had a lot of senior members, a few grad students, and so on and so forth. So let me very quickly tell you, oh, by the way, so altogether there were 85 people in the workshop. It was massive. We had a great time, but it was also way too many people. Like, it was hard to really, like, there were, but by the way, all four teams had about 20 people each. So it was really like, there were critical mass and like, everybody firing on all cylinders. It was great. Where did these people come from? Well, from 23 different countries in all five. I think we still don't have enough researchers in Antarctica, but one of these days we'll get them too. So we had people from all over, still mostly US 14, France 13, but then like, Czechia, India, Spain, you can see the list. So people from all over the world. We even had people from Kazakhstan, the Republic of Georgia, even Cuba, which is quite unusual for American activities because we have all these sanctions against them, but they could come to Europe. Anyway, so this was fun. A lot of people from all over the place. By the way, this is why the workshops are fun, because you get a lot of intellectual diversity. People with all kinds of different ideas show up and try to contribute to each other's research. It's a lot of fun. Like I said, we are gender-wise, we are not great, but not too bad. I think this is par for computer science, about 25% women, 75% men. Hopefully it'll improve in the future. We'll see. Like I said, still student dominated, about 53% students, or 55, no, 53, yeah. And 47% senior people. Of the students, mostly PhD students, a few undergrads. There were about 6 or 7 altogether, I think. Yeah. Most of the people are from academia still, about 80%, but we have a pretty healthy industry participation. So 1 in 6 people in the 85 were from industry. So companies actually send people there for the whole 6, 8 weeks or whatever, some significant portion to actually work with us. So this shows you that these problems we're working on are quite relevant to people where, like, relevance is the key driver of whether or not you invest time in it. Right? And of course, a few people, I call them other, but these are things like, if somebody was from NIST, they're not really an academic, they're not really industry, they're kind of quasi something government. Okay. Most of them stayed full time. So 80% of these 85 people, about 67 people, I think, were actually there in Brno all the time. And the remaining 22 were anything from 1 to 4 weeks. So some people were for 2, some for 3, some for 1. So basically, these people were really in residence most of the time. What did we do? Well, so one of the things we did, and this is a legacy of having started including undergrads in our workshop. So when we first got them, we realized, hey, these students need some training, because if they're going to work alongside PhD students and faculty for 8 weeks, we really need to teach them some basics. So we started doing this 2-week summer school, where every day we had a theme and we'd have a couple of lectures and a lab. And we have continued that tradition. So for the first 2 weeks in this workshop, we had lectures on all sorts of things, on speech recognition, on diarization, computer vision. We even had a lecture, because Brno has some local expertise, on evolutionary ML. So these guys talked about genetic algorithms and where they're useful, where they don't work, and so on and so forth. We had an interesting talk from Jan Chorowski. He's one of the people associated with the first use of encoder-decoder models for machine translation. At that time, I think he was a postdoc in Yoshua Bengio's lab. And the attention ideas are basically other than the transformer paper, these guys had the idea of attention around the same time. Then, of course, each of the teams gets to do a little tutorial, because one thing we do want in the summer workshop is, even if you're a PhD student in one of the teams, we don't want you to just sleep through the talks of the other teams or not know what they're doing. So each team spent a whole day training all these other students on what their workshop team was doing, so that you had functioning knowledge of what each research problem was. You did some hands-on lab stuff on it. So overall, you come back from these workshops with a very well-rounded experience of all the topics that people worked on, right? During the workshop itself, well, life is usually just busy. We had some fun things every day. So every afternoon we had a cookie break. So people go socialize, eat cookies. On Fridays, cookies get upgraded to ice cream. Yeah, of course, in the beginning, we had an opening presentation, and towards the end, we had 2 full days of technical presentations. Each team gets about half a day. So if you want to think in conference terms, this is like saying I have a special session of 3 hours where I'm going to talk about all the things we accomplished this summer. So each team does a pretty detailed dive into all the research they did. Right. So, and of course, it's not just that we work on these things. We also get some external people to come and talk to us about other fun things. So we had a whole bunch of plenary talks, and these are some fairly accomplished people in their various fields. And they came and talked to us about various things, not necessarily related to the workshop. I mean, some of them, for example, Barbara Schluper, she just talked about linguistics. And when she says cross-layer models, we're not talking neural nets with multiple layers. She's actually talking about layers in the brain and layers at which you process certain types of stimuli and other layers at which you process other types of stimuli and how they talk to each other in order to comprehend speech. Right? Ramani gave a talk not about deep learning in particular, but just the idea of differentiable models without any reference to neural nets and how they influence how engineering systems can be designed and optimized and so on and so forth. Javier Serra, he basically works on music understanding. His whole career is like, how does one understand music? And this means both people and not just machines. And he was talking about like, how does one decide whether some music is going to be pleasant and things like that. So very interesting stuff. So these guys come in like, roughly once a week, and you can see there are 7 of them in 6 weeks. And they come in and talk about something, and we can take our minds off our bugs for a minute and go listen to some fun stuff. And suddenly in the middle of that talk, you realize where the bug is, and then you go back and fix it. So those are the kind of things we do in the summer. Right? Okay. So what did we accomplish this summer? So let me just walk you through a few of them. So this is the player part team. Remember, these guys are trying to simulate dialogue, and the particular domain they chose is doctor-patient dialogues because they had certain standard profiles. And in fact, it was interesting because one of the limitations of doctor-patient profile dialogues that they do with standard patients is you have to sample a whole bunch of different ailments, different demographic groups to really train doctors well, or for that system to be able to summarize things well, if you think of it as just training data. And so they needed a lot of diversity in terms of patient profiles, disease profiles, doctor specialties, all sorts of combinatorial things, right? So they wanted to do this, and they wanted to make sure that the whole dialogue was faithful. And so they had real doctors evaluate the synthetic dialogues and say, yeah, this is bogus. A person will never say this, or no, this is not a real symptom. Versus, oh, this is reasonable, but the dialogue feels a little like hesitant or whatever it is. They found a number of things. So first of all, they found this importance of persona-based prompting. The idea is you're to give the model a fairly detailed description of what persona the model is trying to mimic, including how these symptoms manifest themselves and so on and so forth, because they found that if you don't do that, LLMs appear very good anecdotally, but if you start using an LLM to do patient profiles and say, act like a patient, do this, do that, you realize it can do 3 things. And then it keeps doing the same 3 things. So you really never get any variety in your synthetic dialogue unless you can prompt it with a detailed persona saying, no, you're not a 18-year-old who twisted his ankle. You're an 18-year-old who has some allergic reaction to something. Be different, do something else anyway. And so they found that this really helps improve the realism of dialogue. So they worked a lot on trying to figure out how to create the profile so that the model pays attention to the right components of the profile when generating. Of course, once you start doing this, how do you evaluate? So that's one thing to say, yeah, I have a doctor friend who's going to evaluate dialogues, but they can do maybe 1 a day, right? How do you evaluate 5,000 dialogues? So they actually went looking into automatic means. And they did something very interesting. They said there are these stylistic rule-based ideas about whether there is coherence and whether there is the syntactic flow is good or dialogue, the what do you call those things? The discourse acts are happening properly and so on and so forth. And that gave them one view. And then they also used LLMs as a judge, as everybody does these days. And they found that these 2 methods are not exactly one is good, one is bad. They both have very weird and different shortcomings and weird and different strengths. So they're still trying to figure out how to put this together to do a real multifaceted evaluation of spoken dialogue. Very much an open problem. So you should expect a couple of papers from this group on this topic in the next few weeks or next few months. The third thing they did is they actually tried to synthesize this dialogue, not just produce the text, but also then produce the speech. And this becomes a bit of a challenge because, I have to produce speech, not of a normal person, but somebody who is had a fever and has a stomach ache and is coughing. So producing speech like that is totally non-trivial. And other things are that a lot of speech synthesis systems are good at producing one little snippet at a time, one sentence, two sentences. Ask it to produce a 20-minute conversation and it kind of often goes off the rails, cannot maintain consistency in the dialogue and so on and so forth in the synthesis. So they worked on a bunch of those things and have some nice results. Again, very partial results, no great breakthrough yet. But even the teams that I told you about which had big breakthroughs over the years, it wasn't obvious at the end of the workshop, except possibly in the 1999 machine translation team, that we had actually made a huge breakthrough. Those usually happen a few months, sometimes even a year later. They studied dialogue steering techniques because, for example, when you do this persona-based prompting, the model will still every now and then start thinking that it's not the person it's supposed to be, but something else. Right? So can you do some steering of the state vector and maybe activation patching? So these are ideas which are probably known to you. If not, read them up. And the idea is to sort of look at the latent representation space, figure out directions where the dialogue will go one way or the other, or certain assertion will or won't be made. And then you try to push the system in that direction so that it stays consistent with its persona rather than drift off into its natural way of continuing the dialogue. But if you think about it, these are all different pieces. One is how to study the prompting. The other is how to evaluate the dialogue. The other is to synthesis. The other is to steer the dialogue or to control it in some way. Whether the controllable dialogue people, they look at, these are people who would be looking at mechanistic interpretations and trying to figure out whether there are some controllable parameters in the model and so on and so forth. All this needs to come together. So one of the things they did is a few of the people in the group worked really hard to put together a toolkit where all these things can be pulled together and integrated. And towards the end of the workshop, they were actually able to take all the pieces that they had done and try to produce a few dialogues to see if they could really do the whole thing from start to finish. So this is something very important. This is one of the advantages you have when you have a big team. Somebody can actually be paying attention to integrating things so that you might be working on a little thing, but it gets evaluated in a larger framework where all the other components are also there. Right. So the second team was working on this multi. Yep.
Go back to the previous one. Yeah. So how long are these conversations? Like how long is the tens of thousands of?
It's dozens of turns, or maybe a couple of dozen turns. Like not hours, but minutes.
Okay, so it would be a few hundreds of those.
Off the top of my head, don't ask me to quote a number. I would say a few hundred, yes. Yeah, I would say a few tens of turns. And each turn might be 4 to 8 words, 10 words. These are conversational. Okay. Next, the speech recognition team. They found an interesting way. They said that if you often have these multi-party dialogues, multiple people talking, most recognizers know how to recognize one person at a time. So the key finding was that if you can do diarization, which is actually just looking at the speech signal to figure out who's speaking when, and give that information to the recognizer, saying, okay, speaker number 1 speaks here, 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 and here. Number 2 speaks here, there, and there. Number 3 is here, here, and here. That's probably the best technique we have right now to make progress on this problem, right? So diarize and give the recognizer a hint about where a particular person is speaking. Multi-channel, if you have multiple microphones, of course, you should try and use them. And there are ideas which have been around in the field for a long time. Can you do noise suppression? Can you isolate a speaker? These involve things like beamforming. So they worked on some of these ideas. Again, decent improvements. One of the funny things is normally you say, how do you give supervision to a system, right? Here's a speech, here's some speech, here's a transcript. Okay, that's the input, that's the output. Imagine if 2 people are overlapping and you manage to transcribe what each of them is saying. How do you present the transcript? Is it one after the other? Do you have to interleave them? In what way? Right? Oftentimes you can't hear things clearly enough to mark which word followed which word when 2 people are talking over each other, right? So they came up with a nice idea, which is based on something called a shuffle automaton, where you basically say, I have to produce both these strings, and I don't care which token comes when, as long as in each string you're following the rules of that string. And so it's a nice, simple idea. And it turns out it falls directly drop in like you're doing some standard criterion. So if you're doing CTC training, you can just drop this graph in sort of the normal CTC graph, and you change nothing in your code, and still everything works just cleanly. So nice use of FSTs. So FSTs will never die. And they also looked at the other way around. Suppose I just transcribe everything without worrying about who's speaking when. Can I come back after the fact and get an LLM to diarize and say, hey, these are two people speaking at the same time. Can you just put the words of one speaker and the other speaker together? So there was some work on that. And last but not the least, they created a very nice benchmark. And now everybody in the, most people in the community are looking to it and saying, oh, I'm going to evaluate my idea on this one, which of course, as you know, is a good driver of research. All right. The third team, TTS for all. So this team created data, because a lot of the times the main problem with speech synthesis is not having enough data. And there's a lot of data in the big languages, but these people were working on things like Central Kurdish, Cuban Spanish. How many of you had to look up Kabyle? You did. Where is it spoken? Oh, you'd need to. Okay. It's spoken in North Africa, Algeria, I think. Yeah. And of course, Sarawak Malay is Malaysia, Tunisia is Tunisia. So they actually got speakers to speak. They're like, curating databases is always a hard task, about 50 some hours. And they were able to do good synthesis. And what's interesting is you have Spanish, but Cuban Spanish is not quite the same. And so, they said, okay, let's see how it sounds. And Paula said, no, but okay, you can tell us how it sounds. Yeah, okay. Evaluation, just like a lot of other generative AI, evaluating speech synthesis is very hard. How do you decide if it's good, if it's bad? So it turns out there are many metrics out there, and different metrics have different strengths at different levels of performance. When you're very good, certain metrics work very well to tell you system A is synthesizing better than B. But if you're down in the dumps, you're just barely producing intelligible speech, that metric is useless. Another metric might be good at this low end, but not very discriminative at the high end. So basically, they pulled all the metrics together into one suite so that you could evaluate all of them at once. And when you're in this very low resource setting, this is a very useful thing. So they did that. They looked at a particular codec from SpeechBrain, which produces decent speech, and they were able to make it streaming, because a lot of the times speech synthesis needs to be done in a dialogue setting where you need to produce speech on the fly as you go, right? So rather than wait for the whole dialogue and then synthesize it after the fact. So they worked on some streaming version of this codec. And then they also basically released models, because they were able to train models on these languages and so on and so forth. They, of course, do some multilingual training as well. So it's not like you train each language separately. And last but not the least, the Augie team, the Audio General Intelligence, they created a very nice benchmark, 5,000 QA pairs. And these are probing new capabilities, both in perception and reasoning, and covering many domains of audio, not just speech, music, long form audio. If you have something fairly long, you want to be able to process it all at once rather than one little piece at a time. Because if I want to play you a meeting and say, did Jason agree to something, then you have to find the whole discussion and see where there's debate and wait for Jason to say, okay, I'll do it. And then you can come back and say, yes, Jason agreed to do that. So Jason said he never did. So if you process little bits at a time, boy, if you need to go, go ahead. I'm running a little over. Yeah. So they did things like that. And one of the more interesting things they did is they said, can we do open-ended, free form answers rather than multiple choice? Yes, yeah.
Are those question answering pairs machine generated or?
No. So the audio is genuine. They used a few different techniques to synthesize the kind of questions you might want to ask about the audio, but then it was manually curated. Is that correct, Paula? Yeah, yeah. So no, not machine generated. These are machine assisted generation. Yeah. In fact, I was quite critical of that. I still am critical of that technique. I think you shouldn't do that either. You should actually ask people, hey, what kind of stuff do you want to know about audio? And they say, oh, this one, I would like to know what the tune is. Or I'd like to know what the bow bow in the background is. Is that a dog? And then you ask those questions rather than, oh, my LLM says I should ask about how many people are speaking. Okay. Maybe that's not what anybody wants to know, right? Okay. They created new methodology to assess these free-form answers, right? So it's easy to say if I have a multiple choice question, B is the right answer. If the model gives it, it's right. If not, it's wrong. But what if the answer is more open-ended? So here, they followed this idea where you get the human labeler to listen to the audio, to answer the question, and then write down some rationale. Think of it as a description of the audio. The human says, this is what's in the audio, and that is why I say this. So in that question I told you about what's the relationship between these two conversants, the human labeler might say, oh, this is a mother and a daughter. And the reason is because at one point A says this and B says that, and that's a typical mother-daughter, retort. So therefore, I think this is a mother and a daughter. Right? So they sort of describe something in the audio and say, that's why we think this is the answer. And so now if an LLM gives you another answer saying family members, you have to decide, is that a good answer or is that a bad answer? Is that right or is that wrong? Or is it 50% correct? So they use these rationales. And the important thing is, to evaluate this, you can use another LLM, but that LLM has no audio capabilities. So you're relying on the text capabilities of hopefully a better LLM that only focuses on text. So that way you have the you have the rationale instead of the audio, the question and the answer, and then you have a candidate answer. And you can decide whether the candidate answer is equally good as the reference answer or not, because you have some explanation. So they did some research, they have some studies about correlations and this and that. They created a new data set for pre-training, right? So audio you might think is easy, but it's not obvious how to get lots of audio from the internet. So they worked together with a couple of other open source groups in the world. There's a group called Lion, Laion. Yeah, there's some school teacher in Germany who decided he wants to create free AI resources. So he has a few thousand or a few million hours of audio or something and so on and so forth. And they did do a little bit of core research as well. It's not like they just created a benchmark. They looked at some these group relative policy optimization techniques. They found that the audio tokenization, you can do it at runtime based on the query rather than some query agnostic tokenization of the audio and so on. Yeah, these are the 4 teams. And this is just my little joke about it costs a lot of money. So putting something together like this with 85 people isn't cheap. So yes, we do end up spending a lot of money on it. We get many people to contribute. So like I said, a lot of it comes from industry, Google, Microsoft, Amazon. Esperanto is a European project. And we also use some money that we have been collecting over time from these kind of activities. And this is just the cash and other stuff. But there's also a lot of in-kind support. So we got a lot of computing support. Jean-Zé is a French national cluster. PSC is the Pittsburgh Supercomputing Center. We use our computing. We got some AWS credits. Fish Audio is a small company. They just said, oh yeah, we'll give you our GPUs. We took them, of course. And we had other things. Okay. So what was that reference to the monastery? So this building on the left is the Faculty of Information Technology in Brno, where the workshop actually took place. So information technology is their word for computer science. So this is a computer science department in Brno, and the glass building, as you can see, it's beautiful, and we had labs in there and everything. But across from it is this church. It's called the Trinity Church or something, Holy Trinity Church, Carthusian order, 13th, towards the end of the 14th century, 1375 or something. They built this church, and here's a zoomed out view. So over here is where that church is. Here's where the department is. And these buildings are actually part of the monastery that was attached to the church, right? And this last bit over here, you see this little corner? I don't know if you can see my mouse. That room is where I stayed. And these rooms were meant for monks who wanted to be in isolation. So they're in the corner somewhere. By the way, because these are 14th century buildings, the walls are about this thick, about 1.5 meters, like 3-4 feet, right? And there's no air conditioning in the middle of summer, but that's okay because when you have walls that thick, it doesn't really get all that hot inside. No fans, nothing, but you live there. And in the old days, there was even a little hole in the wall with a window on both sides, where somebody would bring you food, put it in from that side, you'd open it, take it, but you're in complete isolation. You didn't want to deal with the world because you wanted to meditate or do whatever it is you wanted to do. So these are meant for isolation. And it was fabulous because once I was in there, nobody bothered me. And when I wanted interaction, I had to come out of this room, walk all along here, and walk on this bridge over here, and then I was with all my colleagues.
I correctly predicted to that lab meeting that you would describe your accommodations in this. I also said you'd talk about food.
Oh, I didn't talk about the food. But Czech food is mostly beer. No, we did have a great time and we found some really good. In fact, we used to have a ritual. I think every Sunday evening I used to go for dinner to one of 4 Indian restaurants. I said, okay, I'm going to have my Indian food just once a week. Yep. So that's basically my summer. So we'll have the next workshop here. Hopefully you guys will get involved and it'll be fun.